let's look at the properties of planes. Okay, so we want to determine the scalar equation of a plane. Now let's pretend here that this is our plane, okay, and we have a known point, okay, so of where we start. And then, of course, a plane can be defined by its normal vector. Okay, so say that this point that you're standing on the floor. Okay, so we'll pretend that you're standing here, and you can point. Okay, so just any point along this plane, any point along this floor. So the vector of P naught P is then equal to x y z minus x naught y naught z naught, right? Okay, so here you have the vector P naught P. Okay, so P naught P is perpendicular to the normal because it lies on the plane. So P naught P dot n, the normal, is equal to 0 because they're 90 degrees from each other. Okay, so let's just take this generic normal and call that A, B, C, because remember that the coefficients in front of the variable of the scalar equation is then the normal, the coordinates for the normal. Okay, so our dot product is equal to 0. Okay, so let's work out our dot product, and we're just doing this generically here. Okay, and working this out, simplifying, what we get is then the scalar equation. Okay, so let's just see how this is useful. Let's take a look at number 4. This is our example number 4. Let's consider the plane that has the normal, n, and contains the point P naught. A, we want to write the scalar equation of the plane. B, is the vector A parallel to the plane? C, is the vector B normal to the plane? And find another vector that is normal to the plane. Okay, so taking a look at A. We want to find, okay, so the scalar equation of the plane. So we know that from what I had shown you before, P naught P then is equal to, okay, so we're going to take some generic point, P, X, Y, and Z, and that's going to represent every point along the plane, okay? And now P naught, it was 1, 2, and negative 3. Okay, so if we wanted to find P naught P, it's P minus my P naught to get each point. So I can say that X minus 1, Y minus 2, and Z plus 3 is the vector on the plane. Okay, so then we can now say, well, we know this, P naught P dot n is equal to 0. Okay, so again, we know our normal. Okay, let's click back here. Our normal is 3, negative 2, and 5. So in doing so, we can now dot P naught P, X minus 1, Y minus 2, Z plus 3, dot 3, negative 2, and 5, oops, the vector is equal to 0. Okay, so remember 3 times your x, so it's 3 times x minus 1 plus negative 2 times y minus 2, okay, 5 times z plus 3 is equal to 0. So let's expand that out. So 3x minus 3 minus 2y plus 4 plus 5z plus 15 is equal to 0. So simplifying and collecting like terms, so we have 3x minus 2y plus 5z should then give us plus 16 is equal to 0. Okay, so there is our scalar equation of this plane. One last thing that I do in order to check that I've done this right is that, remember, the coefficients in front of these variables should correspond to the coordinates of the normal, and they do. So to follow up on that, there is another method that you can use in order to come up with the scalar equation. Well, you know that since the normal, okay, the coordinates of the normal are the coefficients of these variables. All you would need to find is d. So let's do method 2. Okay, method 2, what we can simply say is 3x minus 2y plus 5z plus d. Okay, it's equal to 0. Now take your point, p naught, of 1, 2, and negative 3, plug it into here, and come up with the value of d. Okay, so in simplifying, d will then just work out to be 16 as we found before. That'll give us our d. Plug it back into our scalar equation and it should give us the same answer. And it does give us the same answer. Okay, so part B wants to know if wants to know if, let's go back and read it again because I don't remember it off by heart. Vector A is parallel to the plane. So we want to know if it's parallel to this plane. So let's write this down. So it's 4, 1, and negative 2. So if this point is parallel to the plane, then that means that the normal and this vector is going to be perpendicular. Okay, so if we know that A dot n, okay, if they're perpendicular, then they should equal 0, their dot product. So let's just check their dot product. Okay. So that gives us 12 minus 2 minus 10, which then is equal to 0. So that means that this vector and the normal to our plane are perpendicular. Okay, so they're perpendicular. That means that this vector is then parallel to our plane. It's parallel. Okay. So part C, is the vector B normal to the plane? So if our vector B is normal to the plane, okay, that means it's perpendicular to the plane, which also means that it should be parallel to the normal. So if we take the normal, you're saying, yeah, could I just then cross it and see if the cross product is 0? But an easier way to do this is to see if they're scalar multiples of each other. Okay, so if they are scalar multiples of each other, then we have, oh, I think I've dropped a negative sign right there. Okay, so there, that's better. Okay, so if they're scalar multiples of each other, that means that they are parallel. Okay, so which means that B would then be perpendicular. So is there a constant or a number that we can multiply one to the other, or one by the other, and get the same result? So in this case, 5. So it looks like if I multiply n by 5, I would get B. So they are scalar multiples of each other. So B, therefore B is perpendicular, if I can spell, perpendicular to the plane. And you want to tell me why, okay? Either by showing me that there is a constant and just writing out what that constant would be. In this case, it would be 5, because B and n are scalar multiples. Okay. Okay, so lastly, D, find another vector that is normal to the plane. So remember in our previous question, we found that any number that, or any vector that is a scalar multiple of n would give us a vector that is perpendicular to the plane, so or normal to the plane. So what we can say is we can take n and we can multiply each of the coordinates by a constant, and that would give us the coordinates for another vector that is normal to the plane. So in this case, I would even simply say, let's see here, I'll write it in just so that you can see it. So what I might even say is another vector could be 6, -4, and 10. Okay. There we go. So that could be an answer for D. Okay, so our final example, number 5, we want to find the scalar equation of the plane containing the points A, B, and C. Okay, so let's use some of the properties that we had learned in order to come up with the scalar equation of a plane given 3 points. Okay, so we have 3 points, and what we need are 2 vectors. Okay, so we'll need 2 vectors along the plane. So we'll say, we'll just take AB for simplicity. Okay, AB. Okay, and so what we're doing here, let me write the points out. So A, so we take a look, -3, -1, and -2. B then is 4, 6, and 2. And C is 5, -4, and +1, round brackets. Okay, so A to B, so 4 minus 3 minus -3, 7, 7, and 4. Okay, so the AB is a vector on a plane, on our plane. So A, we'll do AC. So 8, -3, and +3. Okay, so AC is also a vector on the plane. Now, remember, when we wanted to find the scalar equation of a plane, what we need is a point. We've got lots of points to choose from, and a normal. Okay, so if these 2 vectors lie on the plane, how do I come up with the normal? How do I come up with a vector now? Okay, maybe I'll draw it out for you. How do I come up with a vector that is going to be perpendicular to, say, a plane that is created by AB and AC? Okay, what operation do I need to do? Well, does that look familiar? Okay, cross product. Okay, so basically to come up with our normal, we're going to do AB cross AC. Okay, just when you thought that you could easily forget this until the exam. Okay, so this will give us our normal, which will be the normal. So crossing I, J, K, I, J, K, and we'll write it out twice. So 7, 7, 4, 7, 7, 4, 8, 8, or 8, -3, 3, 8, -3, 3. Cross these 2 ends off. Okay. Okay. So just to make things a little faster, I'm just going to pause it here and actually work it out. So you should try and practice this as well, and we can compare our answer. So for the normal, I got 33, 11, and -77. Okay, so what we can do is actually reduce that by dividing everything by 10. So it's 3, 1, and -7. Okay, so there's our normal. Okay, so now we can take, let's take our point A. Let's take point A. Okay, so what we'll do is we'll say that we'll do this method. 3x plus y minus 7z plus d, okay, is equal to 0. Okay, so we'll find d. So 3, -3. So I'm just using point A now. Plus d is equal to 0. D then is equal to 6, -1, -14. Sorry, -14. Okay, so d then is -4. Then we have 3x plus y minus 7z minus 4 is equal to 0. And there is our scalar equation of this plane. And that concludes our lesson for today, and we'll see you next time.